Bucket sort. Bucket sort is a non-comparison based sorting algorithm that works by distributing elements of your input list into multiple buckets, sorting those buckets independently, and finally combining the result in all the buckets together in order to form the final sorted array. So this is how bucket sort works. This technique is very efficient when input is uniformly distributed over a range, especially when you have very large data sets. If you have very large data sets, distributing into multiple buckets and then sorting separately, that will be very helpful. Let us understand this in detail, exactly how this distribution is helpful. So what you do is, consider you have this as your input array. So if this is your input array, what is the first thing that you should do? You should identify the number of buckets. So let k be the number of buckets you have. What does this mean? If you have k different buckets, you have to divide your input space into k equally spaced intervals. Once you divide that, you can decide that into these particular buckets, these values should go on. How would you decide these intervals? Would you simply divide like this, k different parts, and would you take all those and sort separately? No, this is not how you do. How you do is, you first see what is your input space. So let us say your input space is some value to some other value. This is the range of your input. Generally what you do is, you restrict this range to range of 0 to 1. How you do this is, whatever be your input, you take your complete input and divide all the elements in the input by the largest number. So whichever be the largest number present in your input, take that number and divide everything by this largest number. What happens? Then your complete input space will come down to 0 to 1. So whichever is your largest number, that will get divided by itself, giving the value 1. Whatever other numbers are there, all of them will take some value like 0.11, 0.23, something like this. So the whole range will come to 0 and 1. Next step is, identify the number of buckets you want. Once you have identified, you can divide this space into equally spaced intervals. Just assume you are having 10 buckets. If you are having 10 buckets, what will happen? The range from 0 to 0.1. All the values which belong to the range 0 to 0.1, they'll go to the first bucket. All the values which are in the range 0.1 to 0.2, they will go to the second bucket. All the values in the range 0.2 to 0.3, they will go to third bucket. And so on. This will continue till the 10th bucket, which takes values 0.9 to 0.1. To 1, 0.9 to 1. So this is how you will define buckets. What is the advantage of having buckets like this instead of simply dividing whatever input array is provided? The advantage is that once you put these values into these buckets and you sort these buckets independently, I told you that you have to sort all these buckets independently. So whatever be these buckets, you'll be sorting them independently using a different sorting algorithm. So there you can use any simple sorting algorithm. Generally we use insertion sort or something. So here you can make your choice, whichever is suitable for your particular data set, for your particular situation, that can be used. So in this lecture, we'll be considering insertion sort. Okay. So consider that you already sorted whatever is present in all the buckets. After this, combining is easier. You don't have to combine it like you combined in merge sort or something. This time, you already know that whatever values are present in the first bucket, they are supposed to come before all the values in all other buckets. Because of that, while you're combining, you can simply concatenate all the values in the buckets. What will you do? You know your first bucket is already sorted. So in the sorted list, which is your final sorted list, you'll simply insert all the values in your first bucket because those values are already sorted. You are aware that whatever be the values in the second bucket, they are supposed to come only after all values in present bucket. You already know that in the sorted list because of the way you have distributed into buckets, right? So after this, you can simply concatenate all values of second bucket, then all values of third bucket, and so on. This is how you will prepare the final sorted list. What we'll do, we'll take some numbers and understand this very clearly. After that, we'll write the pseudocode and look at this time and space complexities. So numbers, what we'll do, we'll take numbers which are in the range 0 to 1 so that the process is easier. Let us say the numbers are these: 0.53, 0.18, let 0.66 be the next number. Next number, let us say it is 0.20, 0.35, 0.99, something close to 1, and 0.81. Consider these are the numbers that you want to sort using bucket sort. And how many buckets do we want? Let us say we have only 5 buckets, so it will be easier to do the process. What will your buckets range be? Let us say these are the 5 buckets. Each of the buckets are supposed to be lists, okay? So let us say these are our 5 buckets: 1, 2, 3, 4, 5. These are the 5 buckets. What ranges do your buckets hold? First bucket, this will hold 0.0 to 0.2. What will the second bucket hold? So here it will include 0.0, not include 0.2. Let us say it is like this. Second bucket, it will include 0.2 and it will not include but take all values till 0.4. Third bucket from 0.4 to 0.6. Fourth bucket will take values from 0.6 to 0.8, and last bucket will take from 0.8 to 1, all included, okay? So these are the buckets. I'll call this B1, this is B2, this is B3, this is B4, and last one is B5. So these are my buckets. How will I distribute these values into bucket? My first value is 0.53. Which bucket will it fall to? B3, right? B3, take this is in range of B3. Next one is 0.18. Where will it come to? First bucket. 0.18 will be part of first bucket. What about 0.66? It will again come to, it will come to the fourth bucket, right? 0.66 will be part of fourth bucket. 0.20, 0.20 has to be part of second bucket. What about 0.35? This is also part of second bucket. What else is remaining? 0.99 is remaining, which will go to the last bucket, and 0.81 will also go to last bucket. So at this point, I have inserted everything into my buckets. What is the next step? I have to sort all my buckets independently. So when I try to sort, what happens? Here only one element is there, nothing to be done. Second bucket is already sorted. Third bucket, only one element is there, nothing to be done. Fourth bucket, again only one element is there, so nothing to be done. And what about the final bucket? Here the order is wrong, so I have to change the order. 0.81 have to come first and 0.99 will come second. So as of now, I have all my buckets sorted. How will I create the final list? I simply have to concatenate all these values because I no more need to do any sorting. These buckets are in order. So I'll simply write down all the values as it is. So 0.18 first bucket, then I'll take values from second bucket, 0.20, 0.35. What about fourth bucket? 0.53. Sorry, third bucket, then fourth bucket, I'll take 0.66. Then I'll just concatenate values of last bucket, 0.81, 0.99. So this is how I simply created the final sorted list from this initial unsorted list using bucket sort. So this sorting algorithms looks very simple. What we'll do is we'll write the pseudocode and then we'll try to understand what are the time and space complexities of this algorithm. So when we write the pseudocode and understand this, that means you're good to directly convert it to code, because if you can write the pseudocode, you know what are the logical steps. You can easily convert it to code in any language that you want. So this is why we generally write pseudocode at the end of all algorithms. So let us start with this bucket sort algorithm. This is a pseudocode bucket sort of, let us say, some array A. You have to do bucket sort on array AR. Let this be. So what are the variables you need? One thing is you should know what is the length of array. So we'll store, let us say, in n, we'll store length of array. Next thing is we discussed that we need to decide number of buckets k. So k is your number of buckets. So what we'll do now is we'll take k as n. So there is a reason we are taking k as n here. When you are actually doing bucket sort, you can consider whatever be the value of k according to your requirement for that data set. If you take k as n, you're actually expecting that there will only be one element in each bucket. This is your expectation when you're taking k as n. So if this is the case, then you don't have to actually sort buckets, because in each bucket only one element will be there if it is actually uniformly distributed. So it won't be perfect in all cases, but while writing algorithm, we are just considering that number of buckets will be equal to the number of elements. So you can take this as per your requirement whenever you are sorting. So the next thing is you have to create buckets. Okay. So let us say you have buckets. I'll call buckets as B, that is fine. So B is equal to, so in B is the list of all buckets. What is B? B is an array. And what will be there in this array? This will be an array of size k, right? Size k, because there are k buckets. And what about each of those elements? Each of those element will be an empty list, because inside B will be an array like this. This is an array, and each of these elements will be lists, because you may have to insert multiple elements into each of those buckets. Because of that, B, which is buckets array, this is an array of lists. Okay, array of size k of lists. So as of now, it will be k empty lists in this array. So this is about B. What should you do now? Next thing is you have to insert all the elements that are in your initial array AR to this array B, which is the bucket. So you have to take each element and insert it into the right bucket. How do you do that? For let us say each element in array AR, what will you do? You have to first find out which bucket should you insert to. How do you find out? One way of finding it out is the index of the bucket. Index is equal to, one way of finding out of this is this: you take floor of element into k. So let us say for each element, you're getting into this loop. What will you do? You'll take that element, this is the value of element, okay? Element into you will do k. What happens when you do element into k? So this is interesting. The reason we did element into k is we are presently considering that we divided each element by the largest element of the array. So initially when we started discussing bucket sort, we said we generally want all elements to be in the range 0 to 1. So what we will do is we'll divide all the elements in our input space by the largest element of the input space, which means the largest value you have will be 1 and all the values will be in the range 0 to 1. This is what happens. So just think now, what happens when you multiply each element by k? What will happen? Consider the largest element. Largest element will now be 1, right? Whatever was the largest element in the input, that will now have value 1 because you divided it by itself. If you multiply 1 by k, what happens? You will get k. So you are having k different buckets and your largest value will go into kth bucket. That is the last bucket. What about the smallest value? If something is having value very close to 0, it will go to the first bucket. So you are somehow assuming by using this logic that your input data will be uniformly divided into k different buckets if the data is uniformly divided, right? If data is uniform. So for that you are using this formula. So you can use whatever formula according to your situation. So here this is what we are doing. We are taking floor of element into k, right? So all your elements will be in range 0 to 1. You're multiplying that by k. So it will fit into one among the buckets. You have buckets from 1 to k. So you have value from 0 to 1 and you are multiplying all these values by k. So these will map to these bucket indices, right? This is what we are doing. Index equal to floor of element into k. This will give us the index of bucket. What should you do now? You should go to bucket array, right? Bucket array is b of index. You should go to b of index and then you have to append this element. Let us say dot append element, whatever is your element to be added. So at this point you have that element added into the bucket. After this, what is the next step? You want to sort each bucket independently. So how do you sort each bucket? For let us say for each bucket in B, what will you do for each bucket in B? You have to sort it. So here let us consider we are using insertion sort. So insertion sort of bucket. So for each of the bucket you are going to do insertion sort of that bucket. So this we'll write separately after this. For now consider that each bucket is already sorted. So you did insertion sort and it got sorted. Next step is you have to put all these values into a sorted array. So how will you put all these values into sorted array? So initially your sorted array is equal to, so this is an empty list now, right? Your sorted array, this is an empty list. What will you do now? You have to add values in each bucket into this sorted array. So how will you do that? For each of the bucket, for each bucket in B, for each bucket in B, what will you do? You have to take element, you have to take each element one by one. So inside this you are running one more for loop for each element in that particular bucket, right? Each element in bucket. For each element in bucket, what should you do? You should append that element into the sorted array. So let us say sorted array dot append of element. So you got that element. Each element you are going to append into the sorted array. After you are done with all this, what can you do? You can return sorted array. So this is the complete algorithm. So what you're going to do in this bucket sort, first of all, you have the length of the array in n, then you decided the number of buckets as k. What did you do next? You made an array of size k. This is the array of buckets, an array of size k in which each of the element is a list which can hold many elements. What did you do next? You wanted to divide all the input elements into these buckets. What did you do for that? You found out the index of the bucket to be placed by doing element into k. So before this, you are considering that all the elements are in range 0 to 1. If it is not, you have to do one more thing, that is you have to divide all the elements that are provided with the largest element in your input, right? After this, you found out the index, and into the corresponding index, that is the corresponding bucket, you inserted that element. So like this, you inserted all elements of the input array once you complete this loop. After that, what did you do? For each bucket, you sorted it using insertion sort. Once all the buckets are sorted, you initialized a sorted array, which is an empty list. And into that empty list, you are going to append all the elements of your input buckets. What did you do? For each bucket in B is the list of all buckets. For each bucket, You are going to each element inside the bucket and appending each element into the sorted array. So this is how you are completing bucket sort. Next thing is the insertion sort algorithm that we used here. So let us just write that as well. Insertion sort of array. Let us say you have some array and you want to do insertion sort on it. So you already know this from the insertion sort lecture. We are writing this here so that our pseudocode is complete, right? We did the pseudocode for bucket sort. So it is complete only if you write the pseudocode for insertion sort as well. Otherwise, we already discussed insertion sort in insertion sort lecture. So how do you do insertion sort of the array? You have to start from index 1 to last index. Why are we starting from 1? Because 0th index we don't have to, because we are in insertion sort, we'll insert from unsorted part of array into sorted part of array. This is what you do in insertion sort. So initially, when you have only one element at index 0, that is by default sorted. You don't have to touch it. You have to start from index 1 and keep inserting into the sorted part. This is what you do in insertion sort. So for I is equal to 1 to whatever is the length minus 1. So length of array minus 1. This is the last index. So from index 1, so we are considering array is 0 indexed, right? What do you do for each of these? First, you have to identify whatever is your key. So let us say your key is equal to array of I. Array of I is your key. What do you do next? You have to move all elements in the sorted part which are larger than your key towards the right. So how do you do that? So you will say j, let us say, is equal to I minus 1. Then you will have one more loop while j is greater than or equal to 0, so that you don't go out of the array. And what is the second condition? Array of j is greater than your key. Under these two conditions, what will you do? You have to move array of, in case this condition is satisfied, in case array of j is greater than key, what do you have to do? You have to move it one step forward. So how will you move one step forward? In order to move one step forward, you will do array of j plus 1 equal to array of j, which means you moved that element one step towards right. After this, you have to decrement j equal to j minus 1. So once this while loop is completed, all the elements that are larger than your key, larger than ar of I, they will be moved one step towards right. So which means the point between those, that is point between all the elements which are smaller than key and all elements which are larger than key, this one particular position will be free now. So you can insert whatever is the present element into that position. How will you insert? AR of j plus 1 is equal to key. So this is how you will insert. So this is your insertion sort algorithm. This is an order of n square algorithm, as we already know. So next thing is, we have to understand time and space complexity of this algorithm. So how do you understand time and space complexity? Time complexity, first thing is, you have to divide your bucket sort algorithm into different parts and understand time complexity of each part separately. Then we'll combine everything and understand total time complexity. So how we analyze this is, one important step in bucket sort is to distribute elements into buckets. So this step, here what are you doing? You are distributing your elements into different buckets. So in order to do this distribution, what time will it take? You have a total of n different elements. So considering n elements, distributed into buckets will take order of n time only. Why? Because each element you have to do these two calculations. So it is order of n time in order to distribute it into n buckets. Into k buckets. One more thing, here you are creating k buckets. So you can consider it as order of k. Okay. So order of k and order of n. Order of n time is taken in order to distribute all the n elements into different buckets. So this is one major part. What is the next major part? Next major part is sorting. So here you are doing sorting. We are considering insertion sort. So insertion sort, we know it takes order of n square time. But is it actually order of n square here? It is not, because you are doing insertion sort inside each bucket. The size of each bucket is not n. N is the size of your total input. You divided it into k different buckets. So considering uniform distribution, the number of elements inside each bucket will be n by k. Right? You can consider that the number of elements which will be present in each bucket will be n by k, because you have k different buckets and you are dividing n input elements into k buckets. So you can somewhat consider that n by k is the total number of elements present inside each bucket, considering uniform distribution. So in this case, considering insertion sort, what time will it take? It will take order of n by k square. So this is the time it will take. One more thing, do you actually need to use insertion sort itself, or you have some other ways as well? So in order to consider time complexity, what are we doing here? We are doing time complexity analysis. So considering time complexity analysis to see what is the best scenario, we will consider merge sort instead of insertion sort. So imagine, in case instead of insertion sort, if it was merge sort, then what would have happened? Then this would have been order of n by k log n by k, right? This would have been the time complexity in case it is merge sort. So we are just considering merge sort because merge sort has a time complexity of n log n. Insertion sort has order of n square. So in order to get a better time complexity, while time complexity analysis, we are considering merge sort. What is the next thing to consider? You have to sort how many buckets? You have to sort k different buckets, because this you are running in loop. This insertion sort, you are running in a loop for k times. So in case it is insertion sort, it will be not just order of n by k whole square, it will be order of k into n by k square. Why is that k into? Because you are doing insertion sort k times. For each bucket you are doing insertion sort. This will be order of n square by k, right? You can also write it like this. So this is the case of insertion sort. What if it is merge sort? In case of merge sort, you will have this into k, right? Order of whatever was here, this part is the merge sort time complexity, that into k, because for each bucket you are doing merge sort. So this k and this k will cancel off. It will be order of n log n by k if you are using merge sort. So here, depending on the sorting algorithm you use, you will have different time complexities. If it is insertion sort, it is order of n square by k. If it is merge sort, the sorting time, we are only saying about this sorting time complexity now. So this sorting time complexity, if it is merge sort, it will be order of n into log n by k. So these are the major time consuming parts. What is the other part? Here you are just appending everything onto the list. This will also take order of n, because there are n elements in total and you are appending all the n elements into the final sorted list. So what did you understand from this? Total time complexity will be order of n plus k plus n log n by k, or if it is insertion sort, instead of n log n by k, you have to consider n square by k. So considering merge sort, let us say your time complexity can be analyzed as order of n plus k plus n log n by k. So this is the time complexity of your bucket sort algorithm. And one more thing, if this is the time complexity, what is the space complexity? Space complexity, what is the extra space you are taking? One, you are creating buckets. Two, you're copying all the elements onto those buckets. So considering n elements, you need at least order of n space in order to copy all the n elements. Plus, even if you have no elements, if you created k buckets, it will take k space. So whichever is larger, n or k. So how will you write it? Order of n plus k. So this would mean whichever is larger, n or k, that much space is extra. So your time complexity is order of n plus k plus n log n by k. Space complexity is order of n plus k. Next question is it in place? So in this algorithm, you are creating special buckets, and whatever sorting you're doing in those buckets, which means it is not in place. It is out of place algorithm. And what about stability? Is it stable? We are not commenting on the stability here because stability depends on whatever is the internal algorithm you are using to sort. So here we are using insertion sort. So whichever sorting algorithm you are using here, if that is stable, your bucket sort algorithm is stable. If that is not stable, your bucket sort algorithm is also not stable, right? So that is it about stability. So it is not an in place algorithm, it is out of place algorithm.